I think we're ready to get started. First off, thank you all for making it out here tonight. My name is Levi Zitting. I'm the president of Springfield Devs. I'm also going to be the speaker tonight. While I'm doing this, we're getting started on the stream. I know there's a few people watching. If I can get some messages in chat if the audio is really bad. I'm also trying to present and manage streaming stuff at the same time, so I can't listen to myself. It would be a mess. So just let me know, those of you on the stream, if there's a problem. Before we get started, let's talk about a few announcements. So number one, I want to talk about our upcoming Dev Night. So this is going to be next month, April 5th. We're going to hear from Christopher Bonnick, lovely person over here, a year in Web3, and then also Ben Pomeranke, who's another board member. He's going to be talking about Terraform. He's not here tonight, so he can't give a spiel about it. Do you want to give them a highlight, or is it?
Yeah, so I worked at a Web3 company for about a year, and I'm just going to be talking a bit about how it was, pros, cons of the industry, who I recommend it for, who I don't recommend it for, and if I have some leftover time, just delving into a few extras.
Thank you. Okay. The other big announcement, I already kind of talked about this a second ago, but I'm going to give everyone the spiel again. Squared is a conference put on by the Springfield Tech Council. It is next week on Wednesday. It's an all-day conference. This next slide has those details again. That QR code you can go to use to look at the speaker lineup and then register. It's a completely free conference. So if you have some free time on Wednesday, definitely make it down. We're going to have a few speakers from Springfield Devs. I'm planning on speaking there, as well as Ben Pomeranke has a couple of talks lined up. But there's all sorts of stuff planned, so definitely if you can, make it out to that free event. In some kind of community stuff, actually before I do that, back at our Christmas party, we had some people who won some gift cards from filling out some surveys, but they were not here to receive them. Is there a Jordan Gilmore in the audience tonight? Because we need to give you a gift card. Okay, we'll have to follow up with you later. What about a Kevin Williams? No? We'll try again next month, or we'll reach out to you all over email. But in community announcements, I want to let German have a couple of minutes here to talk about Codify for a second.
Should I stand in front of?
Right here, the camera on the screen is pointed right there.
Hi, can you hear me? All right, so my name is German Cruz, and really excited to hear this presentation that Levi is going to present in just a moment. But I just want to take some time to let you know that I work for a company called Codify under a specific program called Code Labs. And Code Labs is a full-stack web development training program to help you achieve the skills as a junior developer and such. So I'm really excited to announce to you all that we're starting to accept applications starting today and such for cohorts that will start in the beginning of July. Okay, so if you want to read more about this sort of information and know more about it, please visit www.codifyworks.com/codelabs. Now feel free to also, if you have any additional questions, to reach out to me either in person after the presentation or via email. My email is german@codifyworks.com. That is german@codifyworks.com. Thank you.
Thank you, German. If you could throw those links and that contact information into the general channel in Discord so that people can follow up with you later if they're interested. Secondly, we have Zach Bradshaw with the OpenSGF group. You want to come up and say a few words?
Yeah, I'm Zach Bradshaw. I co-organize OpenSGF. We meet every Tuesday at 6 here at the E-Factory. You can find us at our website, opensgf.org, where we have links to our Meetup and Discord channel. It's a great place to learn, teach, and collaborate. Beginners are welcome, or rather encouraged to come. That's it. Thank you.
Thank you, Zach. All right. I didn't get a chance to talk to anyone in the audience. Is there any other community announcements that I might have missed from anyone? Okay. All right. So without further ado, let's jump into the advertised content. So tonight we're going to be talking all about .NET. Give me a second here to switch mics. Test, 1, 2, 3. Can you all hear me? Okay. People on the stream, tell me if that turned out poorly. Okay. All right, so tonight's presentation is called .NET and Why You Should Care. We're going to do sort of a deep dive into what .NET actually is and ultimately like why it's a cool thing that you should probably be using and care about. So before we get too deep into the weeds, I want to start with talking like specifically about what .NET actually is, at least at a super high level. I also need to call out like how cool this slide animation is because I spent way too long on it. Hopefully you're impressed. Thank you, thank you. That was 3 hours. No. So what is .NET? So .NET, this is like the simplest explanation I could come up with. It's an open source developer platform from Microsoft for building all sorts of applications. It's a little bit of a loaded sentence. There's a couple things in there that you probably recognize, like open source means you can go read the code for the whole thing. It's all on GitHub. It's also from Microsoft. It's like sponsored by this big organization, and they've had a major role in its history over the years. And then developer platform, that might not mean anything to some people. Some people might read that and know exactly what it means. But let's talk about what that is. What's a developer platform? I think another way to word that is that it's a developer ecosystem. That's kind of the way that I like to think about it. It's a lot of things all at once. A succinct way to say it is a developer platform or an ecosystem is a set of tools and libraries that accelerate the development of your applications. So it's a whole bunch of things kind of packaged up nice and tidy that make it so that you can be extremely productive and go build things quickly. Now, I want to call out that there's a lot of those developer platforms out there. You have like community-driven ones in ecosystems like the PHP ecosystem and the JavaScript ecosystem and so on and so forth. One thing I want to call about with .NET, kind of their values and their goals in building this platform, is that they try to strike a balance between 4 key areas. They want to strike a balance between productivity, performance, security, and reliability. And so you should see kind of all 4 of those things be like major selling points for .NET. They're like major things that they're always trying to hit on as they are designing this developer platform. So before we talk like technical details for a minute, I think it's really important to do a little bit of a showcase about what you can build with .NET. What can you do with this developer platform? Because some developer platforms are really limited. If you're a PHP developer and you're using those tools, you're fairly limited to just web applications and maybe like command line applications or something like that. And so I want to give you kind of this overview of all the cool things that .NET can do. And I'm also going to like throw out some of the buzzwords about like the names of those tools and frameworks and those kinds of things. So for starters, .NET can do web development, and it's great at it. It's got a few different frameworks, you could say, that are a big part of that. The biggest one is ASP.NET. That's Microsoft's official MVC-style web framework. So it runs on a server somewhere, right? And it responds to HTTP requests. Also, a newer one is Blazor, and this is the .NET's answer to like single-page applications. So it's for doing client-side development in the browser. And specifically, it has like 2 modes. One is a WebAssembly mode, where the .NET code actually gets loaded into the browser and executed in WebAssembly with like almost no JavaScript required. But then there's also a server-side mode where it uses a WebSocket connection to send events to the server, and the server spits back out HTML, and you get a kind of client-side friendly app that responds nicely to user events and all those kinds of things. You can also build mobile applications with .NET. So by mobile, I mean like iOS and Android applications. Specifically, this is using the Xamarin framework, which is these days going out of style. I think it's being officially deprecated by Microsoft. And it's being replaced by what they call MAUI, or .NET MAUI, which is multi-platform application UI. MAUI's honestly a little bit nicer. And this is kind of their new and improved framework for doing mobile applications. You can also build desktop apps with .NET. So that Blazor thing that I was talking about a second ago, they actually have like a web view and a desktop app that loads the Blazor stuff, and so you can use Blazor to build your .NET application or your desktop applications. .NET is also like the official way to go build native Windows desktop apps using the WinUI framework. So if you want to go build like a truly native Windows app that people can install from the store and stuff like that, that's actually a .NET thing. There's other ways to build it too, but .NET is widely supported. And then kind of the other exciting thing about MAUI is it's the same framework to do mobile and desktop apps. So you can build native desktop apps with MAUI. We'll actually get a chance to look at that in a little bit. It's also got great support for doing microservice type architectures and cloud native applications. So it supports like all the serverless environments, right? So if you want to have Google Cloud Platform or Azure Functions or AWS Lambda, those are all, those platforms all support .NET as a runtime, and they have various like adapter libraries to parse the requests from those various platforms and so on and so forth. It also is designed to be run in Docker and containerized and deployed to, like I said, like a cloud native type infrastructure. But that's not it. The list doesn't end there. It can also be used for machine learning, which is really interesting. So there's a library from Microsoft called ML.NET for training machine learning models and also doing predictions based on those machine learning models. Apache Spark is also a really popular library. It's not written in .NET, but there's .NET bindings for it, so .NET wrappers around those kinds of libraries. And there's probably a whole bunch more. This is by no means a definitive list. It's also really popular for game development. So lots of people have heard of Unity maybe, but it's a really powerful game engine, and the default is to use .NET as the game scripting side of things, to write your game logic in and those sorts of things. Monogame is another fairly popular one, at least in the .NET ecosystem particularly. It's very specific to .NET. And then Godot is a more general purpose engine that supports a lot of different scripting languages, but .NET is one of the potential things you can program against when you're building your games. And last but not least, you can also build IoT applications or Internet of Things applications. So they have a whole bunch of libraries for doing IoT-related things. If you have a Raspberry Pi, for instance, you can deploy .NET to that thing, and there's probably going to be libraries for most of the various types of hardware that you'd want to connect to that Pi. So you could like write all that code in .NET. Also, a particularly special call out to this last one. There's this company called Wilderness Labs that has created the Meadow board, and it's this really tiny little microcontroller that doesn't have a lot of like good specs on it. I think it's got like 32 megabytes of RAM or something, but this thing runs .NET, and it can be used to run like in really low power instances where it's got to run off a battery and those sorts of things. My presentation that I'm actually going to be giving at Squared next week is going to be all about this board. So if you want to see like some live demos of this thing and see some of the code, make sure that you go register and make it to that talk. So that's an overview. There's probably some more things in there. There's plenty I'm missing, but like hopefully you get the idea that the breadth of things that you can build with .NET is fairly wide. There's a lot of different application types that they support, which you don't get with other platforms. The other thing that I want to call out is that .NET lets you do all of these things while still using the same programming languages, the same libraries, and the same tools and techniques for the most part. So what that means is that if you write some code to perform like some business logic or something like that, you could reuse that code across all of those environments. You can drag and drop it into those projects for the most part, because the foundation that everything is built on top of is exactly the same. So now let's start talking some technical bits for a moment. What makes all of this possible? How does .NET do all of these things, right? So for starters, .NET isn't like a programming language, actually. It's this platform, as I've mentioned, and it supports a few different programming languages. There's 3 officially supported ones. You have Visual Basic, which is a little bit older. It's a very like entry-level programming language, meaning it's like easy to read and understand, but not the most powerful thing in the world. It's been around for a long time, and Microsoft still does officially support it. It's not the most widely used thing in .NET these days, though. You also have F#, which is Microsoft's official fully functional programming language. So if you've ever used a hardcore functional language, you'd probably feel right at home in F#. It's also still not that popular, but officially supported by Microsoft. The most popular one by far, though, is C#, which is Microsoft's, it's the object-oriented language of the bunch, or the most object-oriented. These days, it's been taking a lot of functional things from F# and integrating them right in C#, which has kind of made it like a superhero of programming languages. It's also important to mention that because of its popularity in this ecosystem, it's fairly common to run into instances where someone will use the term C# and .NET interchangeably. They'll say one and mean the other in many cases. And although that's not technically correct, it's common enough. But from a technical standpoint, you can have .NET without C# because those other languages are supported, but there's no way to really have C# without .NET. C# is a piece of .NET, if that makes sense. I also want to take a minute and talk about the various tooling pieces that go into .NET. So you have one really important key piece to the .NET platform is what they call the base class library, or the BCL. And this is essentially, another way to say this is it's the standard lib for .NET. It's the standard classes and functions and interfaces that all .NET applications just have access to out of the box. For instance, one example I like to throw out here is if you need to make an HTTP request in your application, there is an HTTP client class. And in almost all of those execution environments that I talked about a minute ago, they all have access to that class, which is really great. It's this great standard to build everything else on top of. You also have NuGet, which does package management. That's a lot like NPM from JavaScript or Composer from PHP. It's both the online services that host all of the source code for these libraries, as well as the client applications to install them into a project. They're both called NuGet. You also have Visual Studio. I don't know if anyone's ever heard of that, but that's the official IDE from Microsoft, Integrated Development Environment, for building .NET applications. It's supported on Windows and Mac. They're wildly different versions. It's important to note here that it's actually not the only IDE that you can use. We'll talk more about that in a second. And then lastly, a really important piece is the command line tools. So there's like a .NET command that you can install, and it does a whole bunch of things in this ecosystem. It's responsible for scaffolding out new projects. So if you want to generate a new project from a template, that's what the .NET CLI does. The .NET CLI also is responsible for actually installing packages and managing them, as well as running and building your projects. All of those things happen with the same command here. You don't have multiple tools that you've installed. And because you can basically do everything with this platform through the CLI, it means that you especially don't have to use that IDE. That wasn't always the case. For a long time, you really did need to use Visual Studio or something like it in order to be effective in .NET. But these days, that CLI tool makes it so you can use Vim or VS Code or any simple text editor to write all your .NET code in, and then use the command line tools to build and run the code. So these next few slides are some pretty nerdy slides, I'm not going to lie. I really like getting to the low-level aspects of what I'm working in. And I'll fully admit that that's not for everyone. And so if you're kind of a beginner and most of this doesn't make sense, that is okay. The reason I add these is I do think it's important to at least have some idea of what's happening underneath the hood when you're talking about writing code. What is this foundation that you're building on here? So know that I'm starting to get into some low-level details, but I still think that it's fairly important. So a key piece of this platform as well is the compiler, which has a few implications when you talk about it. It means that it kind of implies that there's a little bit of complexity in actually working in this platform, and that's kind of true. If you're used to a JavaScript or a Python, you can just have a source code file and then say Node.js that file and it runs it, right? Or if you have a PHP file, you can say PHP and just run that file. That's not quite the case in .NET. There's actually a compilation step that all the code has to go through first, because there is no thing that just executes that kind of code on the fly. There's some additional layers that it's built on top of. So this compiler, in the .NET ecosystem, it's called Roslyn. It's not super important that you know its name, you just need to know that it exists. And this compiler has quite a few responsibilities. It's responsible for doing code analysis, like static code analysis in your .NET projects. So having an understanding of the control flow of your program and knowing like when to generate a warning or something along those lines before the code is even compiled. It's also the tool that is ultimately going to power what we call a language server. So whenever you have an IDE like Visual Studio, it needs to talk to another program to get information about the code on screen in order to like put the red squiggles when you wrote the wrong thing. That's a language server, and the Roslyn compiler is responsible for making most of that work. Another piece here that also has a lot of implications is that this compiler is responsible for type checking. And that's because the .NET ecosystem is a very strongly typed ecosystem. Most of the code that you write in whatever language, it has to be very type aware. So if a variable says it's a string, it can only ever contain strings. It can't ever contain integers or an object instance or any of those kinds of things. And so the Roslyn compiler, it does a bunch of checks as it's compiling the code to ensure that you're maintaining consistency in a type-safe way. The compiler also does like auto-formatting for you. If you ever want to like format all your code, the compiler will manage that. If you want to refactor your code, like do a rename operation for a method, ultimately the Roslyn compiler is going to do that kind of thing. And of course, it also does the compiling, which takes me to the next slide here, which is what does it compile it into? And so before I talk about that, I want to kind of talk about a couple other languages for a moment. So C and C++, these are big languages that they commonly require, or they always require a compilation step, right? And that kind of compilation is actually quite different than the compilation that's happening in .NET projects. So what C and C++ are doing is when they run through the compiler, you're targeting a very specific type of processor that has very specific set of instructions, and it is compiling your code into those native instructions, into assembly code. It's like essentially the lowest level that you can get from a software perspective. And that code can only ever run on that one type of CPU. Well, what .NET is doing is when it compiles your code, it compiles into what's known as a bytecode. And a bytecode it looks a lot like assembly code, but it's assembly that doesn't exist on any real processor at all. Instead, it is entirely virtual. Specifically, it needs to be executed in what we call a virtual machine, which we'll talk about in a second. But it's important to just understand that your code doesn't get compiled directly down to the lowest possible level. It gets compiled into this bytecode. And there's a lot of advantages to like having a bytecode. One of the biggest is that once you compile it, you don't actually have to recompile it for other processor types or for other platforms. That same bytecode can be sent to those other platforms and just run without any problems. I also think it's important to mention that when you're talking about languages like JavaScript or Python or PHP, underneath the hood, they're actually doing a very similar process. They convert the code you write into bytecode, but they do it on the fly the very first time you run your program, whereas in .NET, they do it ahead of time. They do it before the program even runs, which means that they actually have a chance to make some like optimizations that might be more expensive for another platform to do kind of thing. So all that to say that if you try and analyze it from a performance perspective, .NET code is a lot more similar to, in terms of performance characteristics, to something like a JavaScript or a Python or a PHP than it necessarily is to C or C++, because there's still a layer in between where it doesn't get to talk directly to the CPU. Hopefully that makes sense. Here I have like what some of this bytecode looks like. It is not important for you to understand what any of that means. I don't even know what any of that means. But just note that whenever you write code for .NET and it gets compiled, it's getting turned into something like this. Also, I should mention what CIL means. That is the name for the bytecode that .NET compiles everything to. It stands for Common Intermediate Language. It's had a few other names over the years. It used to be called IL, or Intermediate Language, or MSIL, Microsoft Intermediate Language. CIL is the current term that everyone is using. So with that being said, Now we move on to this virtual machine part. And it's called the CLR, or the Common Language Runtime. So this is a piece of software that needs to be installed on whatever machine is going to run the code, and it is responsible for taking that bytecode and executing it, and actually converting it to CPU instructions on the fly. So it is the de facto .NET virtual machine. Remember how I said the bytecode doesn't run on any existing processor? The only one it does is this virtual processor that exists in the CLR. The CLR also has a few other responsibilities. It does JIT compilation as well. JIT compilation is where if there's a method that is being called thousands of times during the execution of your program, the CLR will actually compile that specific method directly into native assembly instructions, so it can be really, really fast. The CLR is also responsible for all the memory management in .NET. It's important to understand that .NET has a garbage collector, which means that as you're creating new objects and working with them and then getting rid of them, that memory is not necessarily freed up right away. Instead, there's a garbage collection phase where your code is paused so that the runtime, the CLR, can go find all those objects that aren't referenced anymore and actually go clean them up. It's got lots of advantages. You don't have to manually worry about your memory anymore, like you would have to in C or C++. But it does have that kind of performance trade-off where every once in a while your program is just going to pause while it tries to go clean up a bunch of this memory. It's also important to note that type safety isn't just at a compiler level, it's actually at the runtime level. So the type information that you write actually makes its way into the final code, and it means that the runtime actually does additional type checks while your code is running. If it sees an inconsistency where data doesn't match up the way that it thinks it's supposed to, then it will actually blow up and tell you, no, you can't do that kind of thing. It also means it's responsible for doing the exception handling and preventing super hard crashes. It fails in a safe way that lets you write code to try and capture those failures and recover from them. Okay. Now that's enough for most of the technical slides. Let's look at what a .NET project looks like in practice. So right here I have the simplest possible .NET project that I can generate, and that's in this screenshot on the right here, and then kind of a breakdown of what a bunch of these files and folders mean when you're looking at any given .NET project. So the most important file in here is this one that ends in CSproj. It's also important to note that this is a C# .NET project. This layout would look slightly different if you were using F# or Visual Basic or one of those other languages. So the CSproj file, it contains a whole bunch of really important details. Number one, it defines what a C# project actually is, and by convention, the file name should match the parent directory that it's in. So this name right here and this file name are supposed to match, and that whole structure is considered a .NET project. Inside that file, you'll see things like build configuration, so if there's any additional build steps necessary to run all the code, that will live in there. It also is where you keep all of your dependencies. I would say that the analogy here to some other platforms is this is a lot like a package JSON from the JavaScript ecosystem or a composer JSON from PHP. Contains a lot of those kinds of settings, but kind of more than just that. This SLN file, it's what we call a solution file. This is a file that lives outside of the project, and it can actually organize multiple projects together. So this is the file that helps you do mono-repo management. So multiple projects in the same GitHub repository or something like that. So it's connected to all the projects and understands how they're related. The CS file that's in here, this is simply just a C# source file. All the source code that you write, all the C# code, it's going to go in .cs files. These next two, the OBJ or object folder and the bin or bin folder, these you actually don't see most of the time. If you launch an IDE, it'll actually hide these from you because they're somewhat of an implementation detail. Essentially, these are both created by the compiler whenever you run your project. So the OBJ folder contains what we call intermediate files or object files. If you know anything about compilers, that probably makes sense to you, but the idea being that every single source code file has a corresponding file in OBJ that is just that file compiled, and it makes it so that the compiler can only recompile the one file that you changed instead of the entire project all at once. So it's there as kind of like a performance trade-off from a compiler's perspective. For the most part, you can ignore it. The bin folder is a little bit more interesting. When you build and run your project, the final thing that's actually executed lives somewhere in that bin directory. And when you publish your project, which means build it for production and like spit out the final thing, it will be in that bin folder. So all the executables, also all the resources and like dependencies and those kinds of things, they also get put into that bin folder as it gets compiled. Another technical slide here, but it's an important piece to understand, is this concept of assemblies. If I had dropped down that bin folder, we actually would have started to see some of these files. But assemblies, they are, specifically the definition, which doesn't make a lot of sense until it's explained, they're considered the unit of deployment and versioning in .NET. That's like a fancy way to say that it's like what is outputted when you finally compile a program. So whenever you compile your program and you're ready to deploy that thing to a server or to some user's machine, the thing you'll be deploying is what's called an assembly. And these assemblies, they can take on a few different types. There's what we call process assemblies, which are like actually executable files, or library assemblies or .dll files that just contain like all these like a library file has nothing, like no entry point to actually like run any code. It's specifically just other classes that your project might depend on or those kinds of things. As I mentioned here, they contain all the compiled code, various resources, and metadata like version numbers and some stuff like that live in these things. It's also possible for one dependency or one assembly to depend on others. And the other reason that it's important to note this is these are the actual things that the runtime expects. So that CLR is what it's loading these files, these assembly files, into memory and executing them. One more thing that I'll mention here on assemblies is that a .NET project, by default, when it's compiled, it produces a single assembly. And if you had multiple projects in here, each one of those would produce a separate assembly that goes with it. So that's kind of the simplest way to think about it. You can kind of think of assembly as all of your project smushed into a single file, right? And compiled down into the lowest level format there. It is also possible for a project to spit out multiple assemblies, but that's not necessarily the way that it happens most of the time. Most of the time, it's a single project to a single assembly. Okay. Didn't have a good place to put this slide. It's really important, though. .NET has had a little bit of a checkered past when it comes to naming like the different versions of .NET. It's not that bad. It's not as bad as something like Java. No one throw rocks at me for that one. But so there's been a few different versions that mean very different things. And so I want to get that out of the way here and also talk about kind of some myths around .NET for a second. So I don't even know how old .NET is. It's like more than 20 years old. It's been around for a long time. And .NET Framework was essentially what was there in the very beginning. And Microsoft has released major updates to that over time. They went from version 1 to 2 to 3 to 4. These framework versions were actually shipped with Windows. Microsoft made Windows, and they had kind of made .NET to be a platform for Windows, which also means that .NET Framework was actually Windows only. You couldn't develop on any other platform. You couldn't really deploy to any other platform. It was very much a walled garden there. And then several years ago, I want to say like 2014, 2015, Microsoft had kind of a big change. This is around the time when they started to become much more open source as a company in general, and to focus more on things like Azure instead of like Windows licenses from a business model perspective. And so they released .NET Core. And .NET Core was the first open source version of .NET, and it was the first cross-platform version of .NET. So no longer did we have this Windows-only dependency on .NET. It was stripped down, though. There was a lot of the base class library from Framework that was not there in Core. But you could do things like build web applications. ASP.NET, I think, was one of the first things that was really supported by .NET Core. And so you could go deploy your server-side applications to a Linux server now instead of a Windows server. And there were several major versions of that. We had .NET Core 1, .NET Core 2, and .NET Core 3. And from there, that ecosystem had matured to the point where Microsoft no longer wanted to actually ship any more updates to .NET Framework. And instead, they wanted to unify these kind of two various forks they had of .NET into a single .NET version. And so these days, there is no .NET Framework. I mean, there is, but it's old and not getting updates. There is no .NET Core, because it's old and not getting updates. There's instead just simply .NET. And so when they released .NET version 5, that was this unified version where no longer was it stripped down as .NET Core was, and no longer was it Windows only, but it covered all the surface area. So even though they have a little bit of this version history nightmare, they've mostly fixed it. The version numbers are consistent from here on out. They actually release a new version of .NET every single year in November. All of the even numbers, so we've had .NET 5, .NET 6, and currently we're on .NET 7. But all the even version numbers are actually LTS releases, so they get security updates for up to 3 years or something like that. But that's their cadence that they plan to continue to release major updates with, is every single year. So it's not as bad as it used to be. So for the next few slides here, how are we doing on time? Not too bad. So in order to really show demos and show code, we're going to have to show some C# at some layer. So I want to give a quick overview of the C# syntax. There's so much I'm not going to be touching on because it's honestly quite a big language. It's a fairly simple language, but there's quite a bit to it. So I'm going to try and give some of the highlights and the important pieces. So what we're looking at here is a fairly simple C# program. And the first thing that I have highlighted here is this class program definition. And the reason that I highlight this is that in every C# file, you have to write all of your code inside of a class, or at least some other type. What I mean by that is if you think about JavaScript, you can kind of just declare a function wherever, right? You can do the same thing in PHP. You can't do that in .NET. Instead, that function would have to be a part of a class or an interface or some other, there's only a handful of top-level supported types. Everything else has to be nested underneath that. So in here, we have this class program, and then we also have this method main. This is specifically a static method, which means we don't have to create an instance of this program class. We can just reference the program class directly and say program.main. We don't have to create a new instance and then call main on that object, right? To also break this line apart a little bit, over here we have our list of arguments, and we actually have a type definition here. So this is saying that this argument args has to be an array of strings. It can't be anything else. And then right here where it says void, this is actually where you declare the return type of a method. So in this case, this method doesn't actually return anything, so the proper return type is void. But if this method returned a string, we'd put the keyword string there. If it returned an int, we'd put int there, so on and so forth. This is some code that shows us how to declare variables in C#. So we have the type of the variable on the left, the name, and then its value. Also, there is a var keyword in C#. I have that kind of commented out underneath it that does essentially the same thing as this code. You might think that because the type is missing, now that variable is totally dynamic, but that's not the case at all. The compiler actually just creates the type for you. It compiles it down to the code above because it's able to figure out the type based on what you assigned it. It's able to see that, oh, there's a string on the right, so the variable obviously has to be a string. Another important piece of code here is this namespace. So in C#, and this is actually kind of more of a .NET thing, all your types have to live inside of a namespace, and you do this to prevent naming collisions. Because if some other file has a class called program, maybe even another library, you don't want that to clash with your class program here. And so you provided a unique namespace here at the top of your file. And now that means if you ever want to reference this class in another namespace, you actually have to explicitly add that to your code somewhere. Which, speaking of that, right here is an example of using another namespace. So this console class that we're calling WriteLight on it lives under the system namespace. So in the .NET base class library, there's a namespace called system, and where all of this functionality is defined. And so what we do is we add this line up here using system to say that we want access to all the types that are available from the system namespace here. We could rewrite this code without the using statement if instead we just said system.console.writeLine. The using statement is kind of just like an import, if you will, to prevent us from having to write these fully qualified names. Some really straightforward ones. This is like what basic control flow is going to look like in C#. So an if-else, right? This is a for-in loop, so if we have an array or a list or any of those collection types, we can loop over them like this. We also have try-catch blocks. It's also important to note that in that exception section there, we're referencing essentially a class called exception. And if we wanted to only catch exceptions of a specific type, we would list that type there instead. And it would only catch on that specific one. Now this does catch basically everything because all exceptions in C# are supposed to inherit from, or all exceptions in .NET are supposed to inherit from exception. C# also has what we call properties. So properties are, like they have fields first off. So this private int age, this is what we call a field on the class. It's a variable attached to the class to store some data on it. But there's also this concept of properties that kind of wrap the field. So the field is private, which means that no other class outside of this file can actually read that data. But this property is declared as public. And the concept behind that is that you should wrap, like it's a general like programming concept, you should wrap those fields such that you could, in theory, add additional functionality behind them. If you wanted to replace the get of that field with now a computation where now you multiply the age by something, you can do that without any of the people who call your code having to change anything that they do. More commonly, you'll see it in this form, where like there is no private field because the compiler will actually generate that for us, and you don't have to think about it. I'm mainly calling this out because as you go look at C# code, you're going to see lines of code that look like that all the time, and they're called properties. So if you ever have questions or need to Google stuff around it, we're talking about properties. You can also have getter properties that like this is a computation being done. You can't actually set full name to anything, but it will be computed and referenced based on those other properties. Another important note here, you'll notice that there is no like this dot in front of first name or last name, but I am referencing these properties that were defined just above them. There is a this keyword in C#, but you are not required to use it. You can just reference any of those properties or any methods, anything defined in the class, you just reference it as if it was a function that just always existed in that scope. Here's another example showing off what inheritance looks like. I also call this out because it kind of looks a little bit weird. There is no extends keyword. Instead, C# uses the colon. So in this case, a cat inherits from this base animal class. Also, it's important to note that if you do want to override anything from the parent class actually has to opt into that. So this virtual keyword here on the method definition, that is what allows it to be overwritten by the subclass. Without this, I believe that this would, without the virtual keyword here, this code at the bottom would produce a compiler error. I'm calling most of these out because we're going to see a whole bunch of them in this demo in just a few minutes. So what we're talking about here is called attributes. So attributes are these little things that you can add above class definitions or method definitions or even like arguments. And if you've never, like they're commonly referred to as like decorators in other languages. I know that I've seen decorators in Python and JavaScript. PHP has them these days as well. I believe they actually call them attributes. Essentially, they're a way to add some metadata to a class or some additional functionality to a class or a method, right? So in this case, like this obsolete attribute, this means that you're going to get, I believe, like an obsolete warning in your IDE and maybe even in your terminal every time you call this method. And you didn't actually have to change the contents of the method. You added this attribute to the method, and it just gets that functionality by default. This serializable up at the top, this means that this class can be turned into like some binary data or some XML-like data. And just by adding that, it means that it can do that. Like it'll add a bunch of functionality to this class such that it can be serialized into another format. This one's definitely a little bit more advanced, but it's kind of an important piece to know, and it shows off also one of my favorite features about .NET and C#. So if you've never heard of generics, it's this way to take a type, like when you are working in a strongly typed programming language, and you need to write one class that could work against a lot of different types. I think the most common one here is like if you have a list of things. You need to know, like the runtime wants to know what type of data is in every single item in the list. And so instead of writing like a list of int type, like a class that is a list for integers or a list for strings, you can write just one list that accepts a parameter, in this case called t up at the top, and then you can reference t throughout the rest of the file. And what that means is when you call that code, you can supply that type. And now you didn't have to write tons of different versions of the same class. Once again, this is fairly advanced, so if you have never seen generics before, don't worry too much about the details here. What this ends up looking like in the rest of the implementation is you can reference that type when you're declaring properties. So we're saying that this is an array of something, but we don't know yet as we're writing the class. Instead, that is determined when we create a new instance. When we create a new instance of my generic class, we have to provide it int or string or something like that. And then the compiler will do this replacement for us. All these places that reference t will be replaced by that type. So they're in an argument list or a return type or when declaring a field. This next one, this is kind of one of the reasons I love .NET so much is if you've ever come from like TypeScript, you might know that TypeScript actually also has this generics feature, but you can't reference it in any code. You can only ever reference it in type definitions. So it's only there at compile time. But that's not the case in .NET. What we're doing here is we're actually able to reference that t variable as if it was just any other variable in our program. And we can write really dynamic code because of that. And that's kind of one of the reasons I think .NET is really powerful and really cool is that fact that the type information that is available to you at compile time, a lot of it's also available at runtime, and you can do some really cool and interesting things with it. Okay, that was a lot. I do want to pause for a minute before we actually do the demo. Are there any like quick questions that I can answer? Okay. All right. Come up with some good ones for the end, though. I do have an actual slide called questions. So for the demo, I have a few things. So let's actually go show the demo first. So number one, I have a REST API that I've built. And I've written this REST API in .NET using ASP.NET. And what's really cool is when you use ASP.NET, it actually has built-in support for Swagger. So this right here is a documentation page that was automatically generated for me, essentially based on just the code that I wrote. So this whole project has a single endpoint called sentiment. And what sentiment is what we're about to do is we're going to do what we call sentiment analysis. This is kind of like a machine learning term. We're going to take in some text from a user and try and determine if it's a positive piece of text or a negative piece of text. Like we're trying to determine their sentiment. And specifically, this is in the context of restaurant reviews. So the other part of this is this API, it has a machine learning model. And that machine learning model was trained on a bunch of Yelp reviews that were labeled. So those Yelp reviews, it would have a great review, and then the number 1 next to it to say that it was a good one. And then a bad review, and the number 0 next to it to say it was a bad one. And so there's like 1,000 of those that this machine learning model was trained on. And so it's produced this little file that we can just send sentences into, and it will give us back a result. Like, is it positive or negative? And it'll tell us how accurate it thinks it is. And so what we've done here is exposed a REST API for that machine learning model. So we have a really simple /sentiment that we can send our review into. And what's really cool about Swagger is I can actually click try it out here and provide some arguments. So I'm going to say, great food, fast service. which is an obviously great review. I'll execute this. And our JSON payload we got back is it determined that this was a positive review, and it is 99% accurate that review is positive. And so the reason I built this API for this is I also have a desktop application here. This desktop app is actually running on my Mac. It's like a Mac desktop app. And this talks to that API and provides a user interface to do exactly what we just did. So if I put in, great, or let's do a different one. Terrible food, slow service, or something. And it says it's a definitely negative review. There's some logic in there to try and determine, like, okay, if it's got a low accuracy, say like likely or possibly or those kinds of things. This one, it was super positive that it was negative. So this is like the project, this is the demo, but what's really cool about it is that every aspect of this demo is done with .NET. So the desktop app that we just wrote is that we're showing here, this is written with Maui. So the UI and all the interactions, those are all done with .NET code. The REST API, as I said, is in ASP.NET. And so like this endpoint and all this stuff right here is all powered by .NET. And that machine learning model that I just talked about, that machine learning model was trained with ML.NET. And so let's go look at the code for this. On top of all that, all of these things exist in the same .NET solution here. So to try and break some of this down, first off, we have this project called Sentiment Model. No, sadly. The code will be very big. The sidebar is going to be kind of small, sorry. We have this project here called Sentiment Model, and this is a .NET console application, which means that it's meant to be run in the terminal. And this is the thing that will actually go train the model. So if I come down here, this ml.net file, this is actually the model. I'm going to go delete this. And then I'm going to pop open a terminal, and I'm going to go into the, oh, what's changed? I don't know what's changed, but that wasn't good. One sec. So I'm going to go into the sentiment model folder, and I'm going to say .NET run with the release flag, so it doesn't run in debug mode or anything like that. And so what this is actually going to do is there's this Yelp labeled file, and this is all of that data. There's like 1,000 Yelp reviews in here. And so if I run this, well, apparently I ruined my demo. I wasn't supposed to delete that. Oh no. Okay, I know how to fix this though. I didn't try actually deleting this ahead of time. 1 second. Well, now we get to see what a .NET proj file looks like. Okay, there we go. Now it just trained our model. And I'll put that code back, and I probably need to run it again. I didn't set up my steps here correctly. Okay, the point being, now we have our ML.NET model that we just trained on all that data. This wasn't like a big thing that was presented ahead of time. It just went through all of our data and processed everything. We then also have this, so in here we also have the code to, well, we have the code to train the model. I want to show what that looks like at least for a second. So in here we have this class model, and almost all this code was actually generated for me by the ML.NET command line tools, which I installed with .NET. The kind of like most of the magic here, like most of this code is for loading the file and like identifying the, where is it? Like this right here is kind of where the main magic happens. This is loading the file, identifying the like different columns of it, like which column means what. And then specifically this fast tree binary classification algorithm. This is like the thing that has all the cool math that goes on in a machine learning model, or in all the cool math algorithms to build the machine learning model. So what's really cool about this is like I wrote none of this code. The command line tools actually let me give it my sample data and like identify it on the command line. And then it actually tried a whole bunch of different machine learning models to try and find the most accurate one. It automatically split my data into 2 chunks, one to train the model on, and then one to like verify that the model actually works on the other. And it just did that a whole bunch of times with a bunch of different algorithms to try and find one that worked. And then also the code to consume the model or like send new values into it and get a prediction, that is also in here. But before we show that off, let's go into this API folder. So this is a ASP.NET app. And so like it has this entry point program file that like does a bunch of configuration and those kinds of things to start up this web server. But our logic specifically lives in this controllers folder, which if you've ever worked with a web framework, controllers probably make sense from the get-go. We have a controller called sentiment controller. It lives in this API.controllers namespace. There's a couple of attributes that give it a whole bunch of things. One of them is like automatically registering the route. So this is the routing information. This is what makes it appear at that /endpoint or /sentiment URL. And then down here we have a method called get, and we have this attribute called HTTP get, which means that this is the function, this is the method that the framework will automatically call when an HTTP get request comes in for /sentiment right here. We grab that review from the URL. We create a new instance of this model input, which exists. This model input class actually exists back in our sentiment model project. And then this is the line of code that actually does the prediction. So we format our data in the way that it wants it to, and then we send that model, or send that model input into this predict all labels. It comes back with a score, which with that score, we create a new instance of this sentiment result class. So if I go look at this, the important piece is it has two properties, is positive and accuracy. And so we fill those two pieces of information in with details about the score, which that score is very much like machine learning model, the machine learning language. We also like log to the console. So I don't know if I can show this easily. Let me try. Yeah, so if I come over here, each of those requests that I made, they're logged in this terminal, and right here, that the formatting that the app uses is actually a part of this sentiment result class, and I log it to the console. So over here, there's two versions of it for the two different HTTP requests that I made. And then I just return that result, which is an actual class instance, and what's really cool is ASP.NET actually converts all that to JSON data for me. Because I added this API controller, it knows that the output is likely supposed to be in JSON format, and so I just can return anything I want from here, and it will try to turn it into a chunk of JSON and put the right HTTP headers in place and all those kinds of things. The .NET MAUI app is in this folder, and I'm not a MAUI expert by any means. A lot of this is boilerplate. The main thing that I really went in here and added, and by boilerplate I mean the template added all this for me. Like I said, new .NET MAUI app, and it built most of the structure here. But in this main page.xaml, XAML is like a special markup language that the .NET ecosystem uses when you're doing UI development. It looks a lot like XML with a few differences. And so ultimately, this XAML stuff we're looking at, it actually turns into C# code. So each of these tags here corresponds to a C# class, and setting properties on these tags actually sets properties on the class instance. It's just a nicer way to write that code instead of like this big nested new this, new this, new this, new this kind of thing. So in here, there's a label that represents this guy right here. So we see there's that review analyzer heading label. We then have this entry tag, which is like a text entry box, which is that guy. And then we have our button here. And specifically, both when the entry is completed or the onSubmit clicked, when these events are fired, they call methods that are defined in what we call a code behind file. It's pretty common for two files that are like very intermingled in .NET for an IDE to try and like show them in this nested fashion. So this main page XAML has a corresponding C# file that it goes with. And actually, underneath the hood, if we look at the very top, it uses this partial keyword. you can actually split a class across multiple files, which is what's happening here. The main page XAML and the main page XAML.cs are just two parts of the same class. And this, for the most part, most of this code I actually wrote, but you can see in here there's like this on submit clicked or on entry completed. Those I referenced back in the XAML. So I'm just referencing methods that I've defined on my class right here. And so then if I walk through this code, they both call this submit review function. And one thing that's really cool, I didn't really talk about this, but .NET supports, or C# supports async await. So if I mark my method as async right here, that means that throughout this method I can call await whenever there's some asynchronous operation that needs to go happen in the background. And I don't actually have to write the kind of complicated code to have it go to the background and then come back in another method or anything like that. It all gets to stay in one method. So we grab the text from that text box, we ensure that it's not blank, and then if it is, we just bail. We don't do anything. We don't show any validation. There's a little bit of work to ensure that whatever we grab from the text box is in a format that's safe to put into URLs. So if there was accidentally slashes or something like that, they'll turn that into a special character that's URL safe. And then right here, here's where we actually make our HTTP request. So right here, we're awaiting this client.getAsync. If I go look at what client is, it's a read-only field on our class that is an instance of HTTP client, and we create the instance right here. And this is, like I said earlier, this HTTP client is in the base class library. So any of these apps, if I need to go make an HTTP request to my ASP.NET, I use the exact same class here, and in theory, I could totally share code between the two if I needed to. But this goes to that sentiment URL and passes in the review. It gets it back as JSON. And then this part is particularly cool in my opinion. Remember that sentiment result class that we used back in the sentiment controller to create a new instance here? Both projects are able to use a shared library here. So they're actually both referencing the exact same code. They're not two different projects. There's not two different versions of that class. It's able to use the exact same one. And so in here, there's like a from JSON method, and they actually use a library installed from NuGet called Newtonsoft. Newtonsoft is a really cool JSON parsing library for C#. So right here, this is what turns a string of JSON into an instance of our sentiment result class. We say that we want to deserialize the object, and then we're passing in a reference to our class. This deserialized object is a generic method, so it accepts like T, like we saw from that example. And it's able to use that to go build a new instance of the class dynamically. So nowhere do you see new sentiment result. This Newtonsoft library is able to do that internally, which is really, really cool. So back in main page XAML, we have our result. And if we actually got a result from the API, we reset our text box to be empty. And this display alert, this is a built-in function in Maui to display a pop-up. And so we can just display our result and use that exact same format for display method to spit out the nice version of the text that uses the accuracy and those kinds of things. I believe that that's it for the demo. I'll also say that if, I'll make all this code open source if you want to go through it. 1,000 reviews is not a lot to make a machine learning model on, so don't be surprised if it gets a bunch of things horribly wrong. Earlier when I was testing, I can't remember what review I put in, but just the fact that I left out a period once was enough to turn it from negative to positive because that's just too small of a sample size to actually do sentiment analysis. Any questions about the demo? I got a couple more slides to wrap up here, but wanted to give people a second to ask any questions or look at something a little bit closer. Okay, all right, let's wrap up then. So, that was a lot of content there, a lot of details about .NET. I want to give kind of a recap about why you should care, why any of this stuff is really important about .NET. And it kind of gets into those values about .NET. So I'm going to repeat them again here with a little bit more detail. You should care about .NET because you can be really productive in it. I just showed that like you can build apps across the stack while using the exact same programming languages, the exact same libraries, the exact same tools, right? You don't have to go learn other things to do. You don't have to learn Python to do machine learning, right? You don't have to go learn Java or Kotlin to do an Android app. You can do that with C#. So a couple key points here is that it's cross-platform, right? You're not tied down to any one platform anymore. You can work on anything that you want. I did all of this on a Mac, which if you told that to a .NET developer 10 years ago, they'd call you crazy, which means it's evolved a lot, but it also means that you're really productive in it. It covers most application types. That base class library is huge and contains like a ton of reusable code, and it means that the code you write can be reusable between those application types as well. And there's really powerful debugging tools. I didn't really even get a chance to show off the debugger, but it's very tightly integrated, and like there's a fantastic debugging experience where you can set a breakpoint and like dive into all the nitty-gritty data that exists in your application at that point in time. It's also very performant. Even though I said that that .NET's performance characteristics are a lot more like JavaScript or Python or PHP, that JIT compilation like helps a lot with it being really, really fast. And also, whenever something does require truly native code, there are libraries that do that sometimes. They have to jump down into something written in C or C++. The .NET team has ensured that that interoperability with native code is also really, really fast. And so I don't have any metrics to show you, but I'm sure that you can go find some slides from the .NET team themselves that go into a whole bunch of like performance characteristics about like how many requests per second that an ASP.NET app can do compared to some of the other ones. And it's quite a bit larger because a lot of these things go a long way into making that possible. Like one, for instance, is that .NET supports multi-threading out of the box. So you can like split your workload up across multiple CPU cores. That's not really possible, at least not easily, in JavaScript or Python or PHP without quite a bit of extra overhead. Also, security. I didn't really talk too much about the security aspects of this, but with that backing from Microsoft, there's regular updates to .NET. There's a performance problem, or if there's a security flaw or a vulnerability in .NET, you better believe it's going to be fixed very, very quickly. It's also got really strong cryptography libraries. I haven't used them myself a whole bunch, but I know that like everyone talks about how great the cryptography stuff in .NET really is, because they put a lot of thought into it. And also, like because there's that CLR that loads up your code and runs it, it actually means that all the code that runs in .NET is running in a sandboxed environment. If you are building a C or C++ or those types of applications, they get to run a lot closer to the metal, which is great for performance, but not so great for security if there's a major security flaw. That sandbox environment goes a lot towards security. And then, of course, also reliability. So that strong type system, that, in my opinion, helps make your code more reliable. You're going to make less mistakes as you're writing code because that type system is going to call you out on it. The automatic memory management, that's a big thing that pushes towards reliable applications. You don't have to worry about manual memory management that you might have to in other platforms. That CLR, that runtime, that is very, very stable. Microsoft's been working on that runtime for literally decades. And they still ship updates to it, but it's been there for a long time and it's extremely stable. And probably one of the biggest reasons is that you have support from Microsoft themselves. These other platforms that are community driven, there can be a lot of reasons to go with a large supported platform by another company, if only just for continuity reasons, right? There is no way .NET goes anywhere in the next several years. Not to say that any other platform will, but it's much more of a guarantee when you have a large organization like Microsoft backing this product, right? And that's it. That's kind of my spiel about .NET and why it's so cool and why you should care about it. Are there any questions that anyone has? I know that was a ton.
You mentioned other IDEs.
Yes, I didn't go back into that, sorry. So I use one called, the question was other IDEs that you can do .NET development in. So I use one called Rider, which is from JetBrains. So JetBrains makes IDEs for PHP and Python, and Rider is their .NET version. That's the one that I'm using right here. It's by far my favorite. VS Code can get IDE-like with a few extensions. There's an extension called OmniSharp for like getting a lot more like type awareness in the IDE that's not just beyond basic syntax highlighting. But those are probably the two biggest options outside of Visual Studio is Writer and something like VS Code. Yes? How is .NET with blockchain development? That's a good question. I've never really dived into it. I don't think it's a major market that this platform tries to operate against. I know that there's some that like it's very specific, like this is for doing blockchain dev. I know that the community is very large, and so there's likely libraries for almost anything that you would want to do. So like if you want to do some like wallet integrations or something in one of your apps, like I'm sure there's going to be something there. But in terms of like powering a big blockchain, I certainly don't think that's like a headlining feature, but it might be possible. I wouldn't rule it out. Yes?
How long did it take you to make this project?
That's a good question. I did it yesterday. So like I said, most of this is just like the standard templates. The amount of code that I edited was like 3 files, I think. Everything else was generated for me. So now that also means, like I've done .NET for quite a while and I know what most of this stuff means, but I got a big boost from just what was built in. I think total, I probably spent four-ish hours maybe, just like debugging some stuff. And I had never done ML.NET before at all, and that was probably the thing that took the longest, just kind of like reading through their documentation and stuff like that. Yes?
How would you compare .NET to, say, or the .NET ecosystem to Flutter as far as cross-platform development?
Good question. So Flutter specifically targets, so the question was comparing Flutter and its ecosystem to the .NET ecosystem. So Flutter is very much like for doing mobile and desktop apps, right? And mobile is definitely like the target market here, and desktop apps are a little bit newer. So I've used both. Flutter probably a little bit more. The biggest thing that I would have to say about that is Xamarin being deprecated and Maui trying to like become this new platform. It's meant that it's very early days for that. So to some extent, even though Flutter is newer as a platform overall, in those spaces specifically, it's probably a little bit more established, especially for mobile apps. I've written a lot more Flutter code, and I tend to like Flutter quite a bit. The disadvantage of something like Flutter is Flutter doesn't cover server-side stuff and like microservices and serverless stuff, where .NET covers a lot of that kind of thing. I'd say it's probably much stronger in those areas than it is client-side development. So if I actually had to pick one, I might actually pick Flutter right now, but give Maui a few years and I might change my mind. Yes?
Are memory leakages a challenge in .NET?
Say that one more time.
Are memory leakages a challenge with
Memory leaks? They certainly can be. I would say that they're not nearly as prevalent as they would be in something like a C or a C++ where you're having to do the manual memory management side of things. In terms of like, when would you have to go debug a memory leak? I'd say it's going to happen as often as it would in something like JavaScript or maybe Java too, where there's going to be certain instances where you're always accidentally creating a new instance of this thing and a reference is being kept around, which means that the garbage collector can't go clean it up. But by and large, the garbage collector is going to take care of a lot more of those problems for you. So it's about what you would expect from kind of a high-level language while not taking care of everything, obviously, because it's kind of impossible to solve all memory leaks.
Would you suggest it
For big data projects? Yes and no, maybe. It kind of depends on the problem. Like, when you're talking about an environment that has a garbage collector at all, it means that if you're building like a very real-time system, that garbage collector can certainly get in the way. I remember that I believe Discord put out a blog post where they were talking about a web service written, I think, in Elixir, which does have a garbage collector. And this web service was like critical in terms of real time. It needed to store like unread counts or something like that. So it's dealing with a ton of data, but in a very like fast-paced environment where it can't, like performance problems are noticed by users. And they ran into an instance where they would get big spikes in that performance chart because the garbage collector had to go run. So if it's a real-time instance, then it's possible to still do that in .NET, but you have to be extremely performance conscious and memory conscious so that you don't accidentally trigger garbage collection. Whereas if it's kind of like background processing that isn't nearly as critical for real-time stuff, then it really shines there because you don't have to worry about those kinds of things at all. Does that make sense? Okay. Well, I will be hanging around here for a few minutes afterwards if anyone else has any other questions. I'll also be in Discord. I'm going to share these slides, and tomorrow morning after I write a much better README and fix my bugs, I will share the repository with all the code in there as well. But thank you all so much for coming. I really appreciate it, and I hope to see you all at next month's Dev Night for the Web3 presentation and the Terraform one. So thank you for making it out.